Hey everyone, welcome to Singularity Computers Client Build 12, Part 3. This is the final part of the build log, so I'm going to start this video by finishing the water cooling loops and filling them. After that, there is still a fair bit of work to be done, particularly on the custom wiring. I also need to install the lighting, and finally I'm going to move on to the testing. At the end of the last video, I was working on the water cooling loops, and I had one more section of tube to install before both of the loops were complete. So I've now installed that section of tube in the graphics card loop. It runs between the graphics cards and the pump. And I've set up the build ready to fill both of the loops. I'm actually going to start by filling the CPU and memory loop because a lot of the graphics card loop is in front of it, and I prefer to have the graphics card loop empty so that I can easily dismantle it to get to the CPU and memory loop if I have a problem when I'm filling it, in case of a leak. So I have the usual setup for filling the loops. I have paper towels around the build. It was a little bit difficult to get paper towels in the bottom compartment. I actually had to remove a panel from the back of the case. I also did this to give me line of sight to the lower tube which runs between the two radiators in the bottom compartment. Obviously you need to be able to see your entire loop when you are filling it. I also have the drainage system connected, and I find that this is the most important precaution to take against leaks, because the quickest way to stop a leak is to drain your loop. Now, some loops you may not be planning on installing a drainage system. Some of the more simple loops I've built and the older loops, I didn't used to install drainage systems at all. But I always used to make sure that I designed a part of the loop so that I could quickly and easily dismantle it to drain the loop. So, if you're not going to install a drainage system, make sure that you have that in mind, that you always have a part of the loop you can quickly and easily access. I also have the pump connected to my Phobia modified external power supply. I've modded a switch into this power supply. I still get a lot of questions about this. People ask me, is the dedicated power supply really necessary? Now, there is other ways of powering your pumps to fill your loop. But the best way I find, because it's convenient, it's also safe, is to have a dedicated external power supply. So the options are, you can use the power supply in your build, you can hotwire it, there's guides out there on how to do this. What I'd suggest for beginners though is getting a 24-pin connector with the 2 pins already hotwired. So that way you don't have to worry about really taking any risks. But if you're going to hotwire your power supply, make sure you have everything disconnected except for your pump. And I find that going around and disconnecting all of your cables often after you've already done cable management can really take up some time. And also you're running the risk, if you do get a leak and it ends up in your power supply or in one of the connectors, then it's a risk to run. So the best way is to have an external power supply of some kind. And I used to use a spare 500 watt power supply I had, and I just used to hotwire that and run the pump from it. And that was certainly okay, but it was big and bulky and really took up a lot of space on the desk, made a mess. So having the dedicated external power supply, it's nice and compact. I just leave it sitting on my desk, and I don't just use it for running pumps. I use it for testing lighting, fans, and other components. So I find it's really useful. So I've started to fill the CPU and memory loop, and I'm about to switch on the pump for the first time. The coolant I'm using in this build in both of the loops is Mayhem's X1 Clear UV Blue. And I think it's an excellent choice by the client because it's really going to help to show off the larger diameter acrylic tube I've used in this build, as well as the bends in the tube. Because if you really want to show off water cooling components, the best way is to use clear fluid, because you can see the water cooling components in more detail. It's also good to be doing something a little bit different because I don't often use clear coolant. And I do really like to keep my builds as different from each other as I possibly can. Although that can be difficult because most of what I do is by client request. So I'm now going to fill the graphics card loop. So I've connected the drainage system, which is at the front of the build, and also the pump. So while I'm filling the graphics card loop, I'm going to be leak testing the CPU and memory loop, which is now fully circulating. It's up and running. For both of these loops, I needed to fill the reservoirs 3 times before the loops were fully circulating, which goes to show that they both have a similar volume, and it turns out that the volume was around 1.5 liters. While there's air in the graphics card loop, take a look at the air and coolant flowing through the EKFC bridge. There seems to be a bit of confusion surrounding parallel configurations, particularly when I set up a parallel configuration between graphics cards with Bits Power Crystal Link. I get a lot of comments, and people say that the config is not going to work because the coolant is only going to flow down one side and not flow through all of the water blocks. Well, you can see from this EKFC bridge parallel where the flow is going. It's not the greatest example though, because it's a semi-parallel bridge. It is a quad parallel bridge, but it's split in the middle. So both of the loops are now full, and they've been up and running for about 24 hours, which is about the length of my leak tests now. You certainly don't need to leak test for that long. As I've said many times previously, half an hour is definitely more than enough for a leak test. But the reason I leave my loops running this long in my client builds is more just to get all of the air out of the loops before I start testing, because otherwise the air could affect the test results. A lot of people seem to be very concerned about air in loops. It doesn't become a problem unless you have air in a water block, and even then it has to be a very large air bubble to make any kind of a difference. And still, as long as you have coolant contacting the bulk of the area of your water blocks, it's really not going to make much of a difference, because you still have good heat transfer happening. And the only other time that air can affect the performance of your loop is if it's in small air bubbles flowing around your loop. And the only time you're going to get that is just after you've filled your loop, or if you have a serious problem with your design. For example, if you're running your flow back to the top of your reservoir and you don't have Bits Power Aquatube or the equivalent of running the coolant below the coolant level in the res, or sometimes with bay reservoirs, if they're not full enough, they put air back into the loop. In most loops, there is always going to be air stuck somewhere. I'm now going to complete the custom wiring and install the lighting. You can see that I've started on the cable management around the back of the build. Now this is just some of the other custom cables that I've made for this build. You can see that I've used heat shrink on these cables, and what I always do, unless requested otherwise, is do heat shrinkless sleeving for the main cables that are going to be in full view. Then for all of the behind the scenes cables, I use heat shrink, because for some cables you just have to use heat shrink. There's no choice. So the system is now complete. Before I give you a detailed look around, I'm going to talk about a couple of problems that I had with some of the components. Keep in mind that some of these components were second-hand from the client's previous build, including the memory and SSD. Now, I knew that the memory could be a problem right from the beginning, and I did actually make recommendations, because it wasn't a matched kit of memory. It was 2 separate 8GB sticks and another separate 16GB kit, so 32GB of Corsair Vengeance memory in total, but not a matched kit. And you should always use matched memory for a number of different reasons. Some motherboards won't even work if you're not using a matched kit, and that was the case with this motherboard. It wouldn't post. So once I replaced the memory, it sorted out that problem, and I replaced the memory with a similar kit, a kit of Corsair Vengeance Pro, 32GB, 1600 MHz, 99924, 1.5 volts. To replace the memory, I obviously had to drain the CPU and memory loop and swap the water blocks and also the EK Monarch heatsinks across to the new memory. I also had problems with the SSD. It turns out it was faulty, so I've replaced the SSD with 2 second-hand SSDs I had in stock, And these actually came out of Singularity Beast 2. Two Samsung 830 series 128GB SSDs, and I've configured them in RAID 0, which is a good upgrade for this build. I'm now going to go through and cover the fittings that I've used in both of these loops. I've actually had a lot of questions about the fittings I've used in this build. People are wondering how I've combined bits power fittings with this large diameter EK 16 by 12mm acrylic tube. And it's because I've combined the bits power fittings with EK HD fittings, which you can see here. So these fittings are designed for the 16mm acrylic tube. So coming out of the pump, I've used a 90-degree single rotary fitting, and going into the memory water block, another 90-degree single rotary. Coming out of the memory water block, 90-degree single rotary. Going into the CPU water block, another 90-degree single rotary. And I'm actually going against the flow here, so the flow is going through the CPU water block in the correct direction. I've used a 30mm extension fitting going into the CPU water block and out. Another 90-degree single, two more 90-degree singles on the other memory water block, just a straight EK HD fitting into the radiator. Now around the back of the radiator here, you can't really see what I've done, but I've used two 90-degree single rotary fittings, a 10mm extension fitting between them, and then I've used a 50mm extension fitting, and I had to do that to get enough length because I did use a ½ meter section of acrylic tube, but it wasn't quite long enough. And because I purchased the EK acrylic tube, it comes in ½ meter lengths. So then coming back into the pump, I have a bits power Q fitting, which I often use for my drainage systems. And coming out of the bottom of the Q fitting, I have a bits power mini D plug, a bits power tap, and that's it for the CPU and memory loop. So for the graphics card loop, again, I'm going against the flow here. I've used a 90-degree single rotary coming out of the pump, another one going into the graphics cards, another one coming out of the graphics cards, another one going into the 480mm radiator, then another one coming out of the 480mm radiator down in the bottom compartment. And you can just see this fitting through the back panel here. And then I've used another one going into the 240mm radiator, another one coming out, and another one going back into the pump. So certainly a lot of 90-degree single rotary fittings in this build. I've also used a 25mm extension fitting going back into the pump. So that's all of the fittings that I've used in this build. Now for a look at the custom cables, now that they're installed and managed. You'll notice I've used ModSmart cable management clips on all of the main cables around the front of the build. Take a look at E22's cable combs. I'll put a link in the video description. They give you even more options for cable management. You'll see them in my builds coming up. So you can see the two 8-pin EPS cables, and next to them I've plugged in an RPM sensor cable from one of the pumps. Moving down the right hand side of the motherboard, you can see the 24-pin cable, and below it a USB 3 cable from the two USB 3 ports on the front panel of the case. You'll notice that I've also sleeved all of the front panel cables. Below it is the second RPM sensor cable from the second pump. Moving down, you can see the SATA data cables, of which there is 4. And moving across the bottom of the motherboard is the front panel cables. Now, I didn't actually plug in any of the 4 USB 2 ports on the front panel of the case because the lower graphics card blocks the USB 2 headers. So I actually completely removed the USB 2 cables and ports from the case to keep things as clean as possible. In the corner, you can see the front panel audio cable. Now, when you do custom cables, when it comes time to install them and manage them, if you put the necessary time in and, done a great job, if they're all at the correct length, which is extremely important, you'll find that they just fall into position. And often what I do with custom cables is let them fall into position and just usually I just use cable ties or other cable management methods such as the ModSmart cable management clips to hold them in that position. So this is the position that the PCI Express cables naturally wanted to sit in. All I've done is just clean them up a little bit and fix them into position. For the lighting in this build, I've installed 3 UV LED strips. Across the bottom, a Phobia 30cm LED strip. The wiring for all of the lighting is custom. It's been extended, soldered, and sleeved. You can see the wiring goes across the top of the radiators and connects up with the wiring for the pumps. There's another cable that runs along underneath this LED strip, and it goes up the back of the build where I've installed a Lambtron flex light. This is a 10-inch UV LED strip. I've installed another one of these across the top, and you can see the wiring goes down the side of the 5.25-inch bays and connects up with the wiring for the optical drive. You'll notice that I've used a few of these ModSmart adhesive cable management clips around the build, and I find these extremely useful, particularly in builds with limited cable management options. So that's it for the lighting in this build. Now for a look around the back of the build at the custom cables. Now most of you will have seen how I get my cable lengths for my custom cables. I use a piece of 18 or 16 gauge wire, and I lay it out in the exact position that I'm going to run my custom cables, in the exact cable routing. So this means that I actually plan out all of my cable management before the cables are even made. So I've mentioned that with custom cables, when it comes time to install them and do the cable management, if they've been built properly, they sit in the exact position that you've planned for them. They just fall into position and they're really easy to deal with. So what this means is cable ties and other cable management methods such as the ModSmart clips are not as necessary as you would think. And you can see the amount of cable ties I've used here. This many cable ties is certainly not necessary for custom cables. The only reason I've used all of these cable ties and other cable management methods is because I'm concerned that the cables are going to fall out of position, particularly during shipping. You know, most of my builds I'm shipping internationally, and if they weren't being shipped, I certainly wouldn't be using this many cable ties, and a lot of them could be removed after my builds are shipped. And it doesn't just go for cable ties, it goes for the ModSmart cable management clips and everything else. And this is actually something else you can consider. And this doesn't just go for custom cables. You know, even if you're using stock cables, you can try this. When you first install your cables and do your cable management, strictly tie the cables into position. Tie them exactly where you want them to be. Go overboard with cable ties. Use as many as you need to get those cables exactly where you want them. Then a few days later, once the cables have settled in, you can come back and remove most of the cable ties and other cable management methods, and the cables will stay in position. And this is just, you know, another way of getting your cables even cleaner, because it's great to do custom cables, but when you have all of these cable ties and other methods, it does take from the aesthetics a little bit. Most of it is out of sight, but still it's something to be considered. So you can see what I've done here with the two ModMyToys fan splitters. These actually run the case fans at the front of the build, the radiator fans on the top radiator, and all of the lighting. So there's actually 9 cables plugged in here. I'm really happy with the way the cables have turned out. Considering the amount of hardware in this build, I mean, there's 4 graphics cards, 2 pumps, a whole lot of lighting, there's 10 radiator fans. There is a lot of cables back here. And also the fact that all of them are custom from the ground up. Well, actually, I shouldn't say all of them, because some of the fan wiring isn't custom. I've actually modified some of the... I was able to use some of the existing fan wiring. But building the wiring from the ground up means cutting every individual strand of wire to length, stripping the ends, crimping pins into position, you know, sleeving everything, and new connectors, the whole lot. It is a massive amount of work, but As always with custom wiring, it's definitely worth it in the end. Now, the airflow, the thermals in your build is extremely important, and it's something that needs to be carefully considered and designed. If you want to improve your thermals, you need to work with convection, hot air risers. If you want to avoid dust, you need to have your intakes dust filtered, and you should have positive pressure inside of your case. So all of the intakes in this build are dust filtered, and the 900D does have good dust filters. They're nice and fine. I've used all Noise Blocker Black Silent Pro PL2s except for a single PK2 on the back panel. I have 2 fans at the front of the build drawing air in. It appears that most of this airflow is blocked by the reservoir mod I've installed, but there's plenty of room for the airflow to go around either side and underneath. I have the fans on the 480mm radiator in the bottom compartment drawing the air in and across. The fan in the power supply is drawing the air out through the back of the case. The 2 fans on the 240 are drawing the air across the bottom compartment and out. Then I have the fans in the top, on the top radiator, exhausting the air out through the top panel, and the fan on the back of the case drawing air in. So essentially I have 7 fans drawing air in and 7 fans exhausting the air. But because the bottom compartment is open, the airflow is not going to be equal. So, a lot of the hot air is going to rise from the bottom compartment instead of going directly across. So that's the thermal design in this build. The system is now up and running, and at this point I've been through all of the testing and validation, so the system is ready to be shipped. I'm happy with the placement of the UV lighting. The quality of this UV light is also good, but a lot of it comes down to the Mayhem's coolant. It really gives off an awesome blue glow, and I actually added an extra 30 drops of Mayhem's clear UV blue dye, which almost doubled the effect. I'm shining bright white filming lights on the build, and that's the only way I can film it, otherwise the camera won't focus, so I can't show you what it looks like in normal light. And the glow is definitely a whole lot brighter in normal light. But I am going to include some photos at the end of the build log, which will give you a much better idea of what the UV effect actually looks like. You can see there's a dull patch up around the CPU and memory water blocks that actually glows nicely in normal light. But I guess that area could be a bit brighter, and the way to do that would be with LEDs. But I don't like using LEDs because then you can see the light source and you get this hard light. You can even see the LEDs themselves. So that's something I usually avoid. I'm now going to go through the test results, starting with the power consumption results. At stock clocks, at idle, 150 watts. At load, 960 watts. Overclocked at idle, 200 watts. At load, 1160 watts. So overclocked at load, almost 1200 watts power consumption. The overclock was on the CPU, 4.6 GHz, 1.35 volts. On the graphics cards, 150 MHz on the core, 100 MHz on the memory. I increased the power limit to the maximum and the core voltage by 0.15 of a volt. The memory was running at its XMP profile. Now for the temperature results. For all of my temperature testing, I mathematically adjust my ambient temperature to 20 degrees Celsius. All of my results are in degrees Celsius. For the idle test, I cold boot the system and let it idle for 30 minutes. For the load test for the CPU, I use Prime 95 small FFT for 30 minutes. And for the graphics cards, the Unigen Heaven benchmark for 30 minutes. So the CPU results, at stock clocks at idle, 25 degrees, overclocked at idle, 28 degrees. At stock clocks at load, 44 degrees, overclocked at load, 68 degrees. The graphics card results, stock clocks at idle, 22 degrees, overclocked at idle, 22 degrees. Stock clocks at load, 37 degrees, overclocked at load, 41 degrees. The motherboard results, at idle, 35 degrees, and the hottest recorded temperature was 42 degrees. The PCH results, at idle, 54 degrees, and the hottest recorded temperature was 57 degrees. Now the PCH fan ranged from around 3000 RPM and maxed out at 7000 RPM. At 3000 RPM it is pretty much inaudible. At 7000 RPM it is fairly noticeable. I'd say around 30 decibels. It certainly drowns out the noise coming from the rest of the system. But it's not extremely loud, it's not unbearable, but still I would definitely have liked to install a motherboard water block into this build, but unfortunately for this build it just wasn't an option. I mean, there's no EK block for this motherboard. But anyway, I'm now going to give you a brief listen to the PCH fan at 7,000 RPM, which is its maximum. Now moving on to the performance results, which I'm going to show in screenshots. I'm including stock clocks results and overclocked results, and also results from the SSD RAID 0 array. So certainly some incredible results there. I actually beat a lot of my performance records with this system. In one of the 3D Mark Vantage tests I did, I scored over 70,000. And you could see the massive performance difference between the stock clocks results and the overclocked results. So it's now time for me to conclude this review. And I certainly had a lot of fun building this system. It was great to build into the 900D for the first time. It was also great to use this large diameter acrylic tube for the first time from EK. As I've talked about previously, initially all we had was Bits Power Crystal Link, and that was the only acrylic tube system we had, and it was, such a small diameter, which was what actually put me off using it for water cooling loops for a long time. I only used it between graphics cards. And I considered using it elsewhere, but it was the diameter that stopped me. So having this larger diameter acrylic tube, it's definitely something you're going to be seeing a lot more of in my builds. So that's it. I'm going to be packing up this system for shipping later today. And that concludes Client Build 12. Thanks for watching. Please subscribe, like, and favorite if you want to see more.